Today, we are going to talk about the process of solving other algebraic functions and equations. So before I start working on this section's problems, let's talk about our general rules. Rule number one, we are going to recognize a radical equation. A radical equation will be an equation that involves square roots, cube roots, etc. terms. If you have more than one square roots or cube roots present in one radical equation, then write one radical term on each sides of the equation. With that information given, I would be better explaining this process if we go back and start working on radical equations. So if you look at the first exercise, you will see that it involves two square root terms, and either of them are on either side of the equation, so we are good to start. How to solve radical equations? We have to reduce the radical powers from the equation. So, because we are seeing square root functions, we're going to square both sides, as square of the square root quantity will cancel the square root and the square term and give you the inside argument of either radical terms. So if I square both sides, on the left hand side I will get square root of 2x plus 1 whole to the power 2 is equal to square root of 2x minus 1 plus 1. Note that there are two terms on the right hand side and you are squaring the entire quantity. Also, that will be a good moment for reminding ourselves a quantity square is going to be evaluated by foiling and distribution. So I will say square root of 2x minus 1 plus 1 multiplied by one more factor of square root of 2x minus 1 plus 1 and then start distributing. So I will get 2x minus 1. 1 times square root of 2x minus 1 is square root of 2x minus 1. Similarly, when I distribute the 1, I get square root of 2x minus 1. And I distribute the 1 over 1, I get a positive 1. So as you can see, I can cancel negative 1 and positive 1 and get 2x plus 2 of these square root of 2x minus 1 terms. Then I will take this and put it on the right hand side of the equation. Whereas the left hand side, I simply cancel the square root and the square and get 2x plus 1. On the right hand side, I get 2x plus 2 times square root of 2x minus 1. Of course, we are going to subtract 2x from both sides. That will simplify your equation as 1 equal to 2 times square root of 2x minus 1. See, I still have one radical term which I do not want, and to reduce that, I'm going to square both sides one more time. This time, I will be a little careful, as on the right hand side, I have two terms multiplied, so by the power rule of exponents, the power goes to both 2 and the radical term square root of 2x minus 1. On the left hand side, 1 squared is 1, 2 squared is 4, and square root of 2x minus 1 squared is 2x minus 1. So this has become a linear equation which we are going to now solve. So I get 1 equal to, distribute the 4, you get 8x, and then 4 times negative 1 is negative 4. I will add 4 on both sides, and I will get 5 equal to 8x. Then I divide both sides by 8 to isolate x, and I get x equal to positive 5 over 8. When you are solving radical equations, the one thing you have to be very careful is the domain of definition of the functions used in the radical equation. What do I mean by that? Think about square root functions. You know that the inside of the square root function has to be a non-negative function. So inside must be non-negative. Since I have more than one radical terms, I'm going to check both of them. And the easier way to make sure that that is happening is checking after inputting the algebraic solution octant as the value of x in the given expression and seeing the equality balance of the two sides. So we will try to do that. We will say left hand side is 2 times 5 over 8, that's my algebraic solution, plus 1. And the question would be, is this equal to the right hand side, square root of 2 times 5 over 8 minus 1. And then this plus 1 outside. So let's simplify. 2 times 5 over 8, 2 and 8 will cancel each other, and you will get 5 over 4 plus 1. Question is still a question. Is it equal to square root of 2 times 5 over 8 is still 5 over 4, but this time I'm subtracting 1, and outside there is one more 1. As you can imagine, on the left hand side, I can write square root of 5 over 4 plus 4 over 4, as 1 is 4 over 4. Is this equal to square root of 5 over 4 minus 1 you can write as 4 over 4 plus 1. And I will obtain square root of 9 over 4 on the left hand side. Question will be, is that equal to square root of 1 over 4, as 5 minus 4 is 1 over 4 plus 1. Well, square root of 9 is 3, square root of 4 is 2, so left hand side is 3 over 2. Similarly, square root of 1 is 1, square root of 4 is 2 plus 1. So my question is 3 over 2 equal to 1/2 plus 1, which is 2 over 2. And as we can see that 1/2 plus 2 over 2 is equal to 3 over 2. So finally, we get to say the equality happens. And I get to say whatever number we found out as the algebraic solution, which was 5 over 8, is my real solution. And I would say the solution set for this problem is the singleton set. Means 5 over 8 is the only solution to this radical equation. Now this is one of the most difficult problems that we must solve while solving radical equations. The rest of the problems that we are going to solve in our class today will be pretty similar, but possibly a little easier than the first problem. So if I look at the second problem, I still have 2 radical expressions on the 2 sides of the equation, so we're ready to start at this point. And I'm just going to start by squaring both sides. So square both sides because you want to reduce the radical power. I would like to write down whatever I have said in words in terms of notation. So square root of 2x plus 1 squared equal to 3 times square root of x minus 1 squared. Again, try to remind yourself, when you have 2 terms multiplied and there is a common power, the power distributes over both terms. Left hand side is simple. You cancel the square root and the square, you get 2x plus 1. Right hand side, first do 3 squared, which is 9. Then square root of x minus 1 squared is x minus 1. Simple linear equation. Distribute the 9, you get 9x minus 9. Then you combine all the numeric terms and all the algebraic terms separately. So you get 10 equal to 7x. To isolate x, I divide both sides by 7 and I get the algebraic solution as x equal to 10 over 7. Then finally, we're going to check our solution. And as I said, the easiest way of checking the solution, you take your algebraic solution, input that in place of x in the original equation, see the balance of the two sides. So 2 times 10 over 7 for x, is it equal to 3 times square root of 10 over 7 for x minus 1. So find common denominator just the way we have done last time. So 2 times 10 is 20, 1 is 7 over 7. Is this equal to 3 times square root of 10 over 7? Again, 1 is 7 over 7. So I get 27 over 7 on the left hand side. Is this equal to 3 times square root of 3 over 7? So what you can now do, either you can think of 27 as 3 times 3 times 3 over 7, or you can think of 27 over 7 as 27 over 7, and on the right hand side, the 3 which is outside the square root, push it inside the square root. Remember, 3 from outside the square root, when it goes inside, becomes a square. So I get 3 square times 3 over 7, whichever way is easier for you. If I use the first process, the first way, then because I'm taking a square root, this pair of 2 3's will contribute in 1 3 outside the square root, and I will get 3 out and 1 of the 3 in square root 7, which is, if you check, exactly equal to the right hand side, 3 times square root of 3 over 7. If you do the second process, then the left hand side is simplified, square root of 27 over 7, and see 3 square being 9, 9 times 3 being 27. On the right hand side, I get 27 over 7 as well. In either way, that checked out. It is equally balanced on both sides of the equation. So the algebraic solution we found is the solution of the radical equation. And we will write down the solution set is a singleton set consisting the number 10 over 7, which is the only solution to the radical equation. When you look at problem number 3, I do not directly see the radical sign. But what I would want you to remember, the power 1/3 stands for cube roots or third roots. So it is still a radical equation. So what I do, if you have the root given in terms of fractional power, you start the problem by writing the radical term by itself. So I say 2x minus 1 whole to the power 1/3 should be by itself. How do I make sure that that is happening? I add 3 on both sides to get the radical term by itself. Then the process requires you to take the reciprocal power of the fractional power on both sides. So to take reciprocal power of the fractional power on both sides. What do I mean by that? Your power is 1/3. Reciprocal means you flip that power, you get 3 over 1, which is 3. So you take a third power on both sides of the equation. So instead of squaring, now I'm going to say take the third power on both sides of the equation. Let's see what happens. You have 2x minus 1 whole to the power 1/3. According to the suggestion, I'm going to raise it to the power 3, and that should be equal to, on the other side, it should be raised to the power 3 as well. Recall, the power of power simplifies in multiplication of the two powers. So now I am asking you to multiply 1/3 with 3, which you know is going to be 1. So 2x minus 1 whole to the power 1 is 3 to the power 3, which is 27. So simply I can write 2x minus 1 equal to 27, then add 1 on both sides. So I get 2x equal to 28. Then I divide both sides by 2 to isolate the variable term and get x equal to 14. And finally, I will ask you to check your solution by inserting the algebraic solution in place of x in your given equation and checking the balance of the equality on two sides. So 2 times 14 minus 1 whole to the power 1/3 minus 3 is the left hand side. Is this equal to 0? Well, 2 to the power 4, 2 times 14 is 28 minus 1 whole to the power 1/3 minus 3. Is this equal to 0? 28 minus 1 is 27 to the power 1/3 minus 3. Is this equal to 0? Which number you multiply 3 times and get 27? Well, 3. 3 times 3 times 3 is going to give you 27. So if I take the third root of that, I should get only 3. So that reduces to, is 3 minus 3 equal to 0? Answer is yes. So I get to say that whatever algebraic solution we found is the real solution to my radical equation. And hence I say solution set is given by the singleton set 14. So 14 is the only solution to my radical equation. We will go to page number 2, and on page number 2 we are trying to solve for x equal to square root of 2x plus 4 equal to 0. Again, square root equation, so simply we are going to take the square power on both sides. So squaring both sides, write it one time what it means to square both sides. You say square root of 2x plus 4 whole to the power 2 equal to 10 squared, which means 2x plus 4 equal to 100. And then you subtract 4 from both sides. It's just like solving linear equation, and get 2x equal to 96. So I was subtracting 4, instead I wrote add 4, but I should get 96. Then isolating x by dividing 2. So x is equal to 48. So it's pretty simple so far. Let's check the solution. I say square root of 2 times 48 plus 4. Question is this equal to 10? 2 times 48 is 96 plus 4. Is this equal to 10? 96 plus 4 is square root of 100. And then you know 10 equals 10. Hence, x equal to 48 is the solution. Write your answer always as a set. So solution set is singleton 48. Means the real number 48 is the only solution to this radical equation. Example 5 brings us to two radical expressions. And this one says that round your answer to the nearest thousand. So we're going to use our simple calculator to find the solution and get its decimal approximation to 3 decimal places. But we will still start the solution process by squaring both sides. So square both sides. I will get square root of minus 9x minus 7 whole to the power 2 equal to square root of 5x minus 6 whole to the power 2. So square root and square cancels. I get minus 9x minus 7 equal to 5x minus 6. Add 9x to both sides. Add 6 to both sides to separate the numbers and the letters on two different sides. You get negative 1 equal to 14x. So isolate x, divide by 14 on both sides, and you get x equal to negative 1 over 14. Which now you remember, I'm going to use my calculator to round it to 3 decimal places. Our problem is dividing 1 by negative 14. So I look at the 4th decimal place, which is 4, and that is less than 5. So I erase all the digits after the 3rd decimal place, and it is rounded to negative 0.071. So let's go back. Now we know negative 1 over 14 is negative 0.071. This is your algebraic solution, which you are going to input on the two sides of the equation and try to understand the equality. So square root of minus 9 times minus 0.071 minus 7, that's the left hand side. Is this equal to square root of 5 times minus 0.071 minus 6? We're trying to understand this. When I multiply negative 9 and negative 0.071, I get on the left hand side 9 times 1, so 9. 9 times 7 is 63. 6 is carrying on. 9 times 0 is 0, so 6. So that should be a positive 0.639 and minus 7. On the right hand side, whereas if you multiply 5, you get 5 times 1, which is 5. 5 times 7 is 35. So 3 carries on. 5 times 0 is 0, plus 3 is 3. So that should be a negative 0.355 minus 6. So on the left hand side, now I get, you are subtracting 7 from 0.639. So you are supposed to get 6.361. But all of that is negative because 7 is the negative number here, which is heavier. Question is this equal to, and see on the other side, both of them are negative, so I will get minus 6.355. Now at this point, I'm not going to even be worried about simplifying it any further. Why? Because on both sides, you have square roots of negative numbers, which are no longer real numbers, not real numbers. So the equality that we were trying to check is not going to happen anymore. So we'll say that for the algebraic solution negative 0.071, since both sides are imaginary, they are non-real numbers, this algebraic solution is actually not a solution. Instead, we will go on and say that this radical equation has no solution. The only algebraic solution we found made both sides of the equation imaginary. There is no real equality. So we're going to say radical equation does not have any solution. Problem number 6 has only one radical expression. So you want to see that radical expression written by itself. So we will start by adding 2 on both sides, and we will get square root of x squared plus 3 is equal to positive 2. Then I will square both sides. So I will get square root of x squared plus 3 all to the power 2 is equal to 2 squared. Left hand side is pretty simple. It's x squared plus 3 equal to 2 squared, which is 4. Subtract 3 from both sides. We're going to solve this quadratic by using the square root process. So I get x squared equal to 1. Again, I said subtract 3, but was writing 4. So you get x squared equal to 1. Take the square roots on both sides to get x by itself. Instead, you get absolute value of x, which is equal to square root of 1 equal to 1. So I get 2 solutions. I get x equal to 1 and I get x equal to negative. And I'm going to check my equation's equality on both sides for both solutions. And I write it this way. Checking for 1. Left hand side is 1 squared plus 3 minus 2. Is this equal to 0? Remember, 1 squared is just 1. So 1 plus 3 minus 2. Is this equal to 0? Square root of 1 plus 3 is square root of 4 minus 2. And clearly, as you can imagine, this is 2 minus 2. And that is clearly equal to 0. So I will say 1 is a good solution. How about the other solution, negative 1? If I use negative 1, I get negative 1 to the power 2 plus 3, square root of that, and minus 2. Is this equal to 0? Well, negative 1 squared is nowhere different than positive 1 squared. It's still positive 1. So I still get square root of 1 plus 3. And the left hand side, as it seems right now, should be also equal to 0. So square root of 1 plus 3 is 4. Square root of 4 minus 2. Is this equal to 0? Square root of 4 is 2. 2 minus 2 is indeed equal to 0. And I say that negative 1 is also good. So this is one radical equation where we have 2 solutions. So we'll say the solution set for this radical equation is both 1 and negative 1. So I'm going to use the comma separated list and list both solutions in there. Let's see our next problem. This one is also a radical equation. There is only one radical term on the left hand side, so we can directly go ahead and start squaring both sides. If I do so, I get 2 square root of n quantity square is equal to n minus 3 quantity square. Also remember distribution of 2, so you get 2 square times square root of n square. On the other side, this is the time when we are going to not make that mistake of writing n square plus 9. Rather, we will write n minus 3 multiplied by n minus 3 and start distributing. So I get n square minus 3n plus 9. So you get n squared minus 6n plus 9, and that is the right hand side. N squared minus 6n plus 9. Now see, the left hand side is just 4. N square root of n squared is n. So 4n equal to n squared minus 6n plus 9. That reminds me that now I have a quadratic equation. In order to solve, I need to have all terms on one side. So I subtract 4n from both sides and get 0 on the left hand side equal to n squared minus 10n plus 9. I can solve it by factoring or completing the square or using quadratic formula. Let's try to remind ourselves the process of factoring. The coefficient of n squared is 1. The constant term is 9, so you multiply 1 and 9, you get 9. You're looking for two terms, two numbers that you multiply, get 9, but add, get the coefficient of the n term, which is negative 10. Clearly, your numbers are negative 9 and negative 1. So we're going to rewrite the expression as n squared minus 9n minus 1n plus 9 equal to 0. Now see, the first two terms, you have n as common, so you factor it out, you get n times n minus 9. The second pair of terms, you have to factor out the sign, so minus gets out, and all you can do is 1, and you still end up having n minus 9. So your factors are n minus 9 times n minus 1 equal to 0. So the two solutions I am going to get, the algebraic solutions, are n equal to 9 and n equal to 1. But are these good solutions? So checking. We're going to start checking by putting in first say 9, that's our first solution, in the original equation. So we'll say for 9, 2 times square root of 9 should be equal to 9 minus 3. Say square root of 9 is 3. So 2 times 3, is this equal to 6? Indeed it is. So 9 is a good solution. But how about 1? So again I do 2 times square root of 1. That should be equal to 1 minus 3. But the left hand side, you get 2 times square root of 1, which is 2. Question is this equal to 1 minus 3, which is negative 2? Clearly, it is not. So 1 is not a good solution. So I got two algebraic solutions. One of them is good, the other is not. And I say the solution set for this radical equation is only the number 9. 1 is an algebraic solution, which is not the true real solution for the radical equation. Example 8 is pretty similar, except because I have solved this problem before, I can tell you that the calculations are going to be ugly. What do I mean by that? So first and foremost, remember you're going to make that radical term stay on the left hand side and put that 2 on the other side by adding 2 on both sides. So you get square root of 8x plus 7 equal to 5x plus 2. Now I know, just like the last problem, I will square both sides. And when I do so, I get square root of 8x plus 7 whole to the power 2 is equal to 5x plus 2 whole to the power 2. Left hand side is pretty simple. It's just 8x plus 7. What is 5x plus 2? Well, 5x plus 2 will be 5x plus 2 multiplied by 5x plus 2 because of the square. Then distribute, you get 25x squared plus 10x plus 10x plus 4 which is 25x squared plus 20x plus 4. That's the right hand side. 25x squared plus 20x plus 4. As you can see, it is a quadratic equation. You want all terms on one side, so subtract 8x from both sides. Also subtract 7 from both sides. So I get 0 on the left hand side. The right hand side is 25x squared plus 12x minus 3. Now you will say that, well, I can factor it. But because I have solved this problem, let me tell you that it is not factorable. So I have two options. Either I use completion of square or I use quadratic formula. Remember the quadratic formula? If you have the equation of the form ax squared plus bx plus c equal to 0, then the solutions are given by x equal to negative b plus or minus square root of b squared minus 4ac all over 2a. That's what I am willing to use in this problem. So identify a, b and c. In your problem, a is 25, b is 12 and c is negative 3. So now I will say x is equal to negative b, so negative 12 plus or minus square root of b squared, so 12 squared, minus 4 times a, so 25, times c, which is negative 3, all over 2 times a, which is 25. Simplify, so I get negative 12 plus or minus square root of 12 squared is 144, minus times minus is a plus, 4 times 25 is 100, times 3 is 300, all over 50. So I get negative 12 plus or minus square root of 444 over 50. And 400 over 44 is not a perfect square, so I'm going to use my calculator. And recall I told you, if I do not ask you to how many places you have to round, always round to 3 decimal places. So we are on our calculator. We will first calculate what is square root of 444. So square root 444 is going to give us 21.071. Why? Because the fourth decimal place is 3, which is less than 5. So I don't add anything to the previous decimal place. I just delete all the numbers starting at 3 and I get 21.071 rounded to 3 decimal places. So that means your answers are going to be reduced to negative 12 plus or minus 21.071 all over 50. So you will get two answers, one for the plus and one for the minus. Let's do them. You will get negative 2 plus 21.071 over 50, and you will get negative 12 plus, minus 21.071 all over 50. So the first one, when I do negative 12 plus 21.071, I am going to get 9.071 over 50. And the second one, you will get minus 33.071 over 50. Now I will do the same thing, 9.071, I will divide it by 50 and round it to 3 decimal places. So let's try to do that. 9.071 divided by 50. Rounding to 3 decimal places, I get 0.181. So the first solution, algebraic solution, rounded to 3 decimal places is 0.181. Then you do the same work with negative 33.071. So now your number is minus 33.071 and you are dividing it by 50. Rounding it to 3 decimal places, it's negative 0.661. So these are just my algebraic solution, and I'm going to check both of them in the given equation. So let's first try 0.181, and I'm trying to see it whether the two sides of the given equation are equal to each other. It is 8x, so I say 8 times 0.181, then it is plus 7, and then we are going to subtract 2 and check whether that is equal to 5 times the algebraic solution 0.181. So let's see how much is the left hand side. We're going to get, multiplying 8, so 8 times 1 is 8, 8 times 8 is 64, 6 carries on, 8 times 1 is 8, plus 6 is 14, so I get 1.448 plus 7 minus 2. Question is this equal to 5 times this term, so 5 times 1 is 5, 5 times 8 is 40, 4 carries 1, 5 times 1 is 5 plus 4 is 9, so it is 0.905. Now remember, I was rounding my answer, so it might happen that the two sides are not exactly equal to each other after I simplify, but they should be pretty close to each other. So when I add these two numbers, I get 8.48448, and I want to take the square root of this number, subtract 2, and check whether that is equal to 0.905. So let's take the square root of 8.448. 8.448, and I'm going to take the square root of that. So this is 2.906, and then I'm supposed to subtract 2 from this thing and round to 3 decimal places. So since the 4th decimal place there is 5, I'm going to add 1 to the previous decimal place, and I will get 0.907. So the left hand side is 0.907, the right hand side is 0.905, and they are pretty close to each other. Remember again, I rounded, so the two sides are not exactly equal to each other, but they're pretty close, and I will take it. And I will say 0.181 is a good solution. I have to check the other solution now, which is 0.661. The work is pretty similar. You're going to write 8 times negative 0.661 plus 7, subtract 2, ask yourself, is this equal to 5 times negative 0.661? So I will multiply and add and then subtract. So multiply, 8 times 1 is 8, 8 times 6 is 48, 4 carries on, 8 times 6 is 48, plus 4 is 52, so I get minus 5.288 plus 7. Minus 2, is this equal to, let's multiply 5 now, 5 times 1 is 5, 5 times 6 is 30, 3 carries on, 5 times 6 is 30 plus 3 is 33, so I get 3.305, but all of that is negative. When I do the subtraction, 7 minus 5.288 or negative 5.288 plus 7, I am supposed to get 1.712. So square root of 1.712 minus 2, is this equal to negative 3.305? So I will do the square root of 1.712 in calculator and round to 3 decimal places. Square root 1.712, and then remember, I'm going to subtract 2 from this. So I did it, round to 3 decimal places. Again, the 4th decimal place is 5. So you add 1 to the previous decimal place. You get negative 0.692. So the left hand side is negative 0.692. Is this equal to negative 3.305? Of course not. So then I get to say that, well, negative 0.661 is not the solution to the given radical equation. And hence, the given radical equation has only one solution rounded to 3 decimal places, and that's 0.181. So I'm going to say solution set for this radical equation is 0.181. And that will answer my question. And I will stop here today describing and showing you how to solve radical equations in form of other algebraic equations.